Hi there, this is Ron Rogers, and I'm going to tell you about the flight evaluation I did as chairman of the Airline Pilots Association Aircraft Performance and Evaluation Committee, previously known as the New Aircraft Evaluation Certification Committee. But anyway, um, this is the Dash 8 400. Now, Bombardier rebranded this as the Q400, and we were fortunate enough to get a flight evaluation on it down in Wichita, Kansas. Now, on the left side of the picture is Captain Jack Jarvis. He was a Dash 8 pilot from Piedmont, and Jack was my regional pilot propeller guy. Jack was a good friend. I enjoyed Jack a lot. He was quite a character. We had a lot of fun with him, and he was my regional pilot expert. Unfortunately, Jack has passed away, very unfortunately. But he was my guy. He was a lot of fun to work with, and yeah, it brings back memories talking about this flight evaluation that occurred back just before we turned 2000. Anyway, so that's Jack on the left. In the center is Wally Warner, who was the chief test pilot on the Q400, and of course that's me on the right there. And you notice the paint job on the aircraft, not too terribly pretty. Well, this is a flight test aircraft. It's actually number one. It was the first assembled Q400, and they brought it back from the Canadian facility down to Wichita, the facility down there, to do some flight tests because we have very good weather and stuff down at Kansas. I used to work for both Cessna flight test and Boeing flight test down in Wichita, so flying this airplane out of Wichita Mid-Continent was a very familiar experience with me. Now here's another picture of Jack, and you notice the foam there. This aircraft was so powerful and so fast that it needed to have a lot of attenuation on it to keep the speed down. No, I'm joking there. I was asked by the FAA to chair the the Society of Aerospace Engineers AE4R Radiated Environment Data Accuracy Committee. I was chairman of a committee that set the certification standards for fly-by-wire aircraft, and this aircraft had a few fly-by-wire functions. Not really, it was just the nose wheel steering, but these requirements also pertain to the avionics system. So the basic, what the foam is there, that is the distance where you set the emitter that you do the test on. So if you're not used to that, it looks just a little funny. Now that's one thing I love about these turboprop aircraft. They, to get the length in that, the added increase. This was a aircraft that was typically configured for 70 seats, and you need big engines. And these are Pratt and Whitney's 150As. They're each rated at 4,580 shaft horsepower. And the propellers on there are nice too. They are Dowdy propellers, and they are 13 feet by 6 inches, six-bladed props. So those things are rather massive. And you can see from the side the size of the engine. That is a big engine, and of course, because of the length of the aircraft, the struts had to be reasonably lengthened there. And I'll talk about some interesting aspects on that when it comes to flying it and that. Now here we are back at 4001, the test aircraft, and the yellow arrow points to that little red item there. Anytime you got flight test activity, wires are in orange, flight test devices are typically in orange. This one's a little bit more red than orange. Must be something with the Canadians or that. But anyway, this is a pitot boom that gets far enough ahead of the slipstream. They're sure this is in good air, so they can get very accurate airspeed readings, and that's very important when you're setting the speeds for this aircraft. Now, we were very fortunate that we were allowed to actually fly this aircraft, and I was actually allowed to do stalls in it before they had really completed the entire stall evaluation series. And with a vertical tail like that, a T-tail, that is an issue. Now, it's pretty far back, so I don't think this aircraft would have really much of a deep stall characteristic because the airflow typically wouldn't impact the tail blanket as such. It's got a kind of a thin, long wing there. So it shouldn't be much of an issue, but still, that is an area you have to explore. And we were doing the stalls without a stick pusher installed because they hadn't got to the point where they actually determined where it would fire and things like that. Now, for those of you who are interested in details, this is some information on the aircraft, some basic information, like I talked to you about the engines and the propellers. The aircraft basically we'll talk about a couple of weights here when I talk about my takeoff there, but basically it's an aircraft that's it's 93 feet 3 inches wide, 107 feet 9 inches long, and stands 27 feet 5 inches tall. And one thing I'd like to comment, we interface with these people a lot, and we develop nice personal relationships with them. We go out, we get a few drinks, either up in Montreal or down in Wichita. And we just have a nice relationship, and they sent me this very nice Christmas card. But back to the flight evaluation. Okay, that's a nice cockpit display, isn't it? With the avionics there, the nice big displays. But there's one thing that they're fighting here, and this is a problem with trying to keep a common type rating, because you got the Dash 8, that's 100, the 200, and the 300, and now the 400. And Jack primarily flew the Q400. It's good to have him. I brought him on all my other turboprop flight evaluations just because he's got very good experience in regional aircraft, turboprops, things like that. But he had 12,000 hours, in the Dash 8 Dash 200, so he was the perfect guy to bring along for this evaluation. But one thing that creeps up here, and a problem that creeps in, is they're trying to keep a common type certificate, and they're quite concerned on it. So we've got these nice LCD displays, but they put round dials on them instead of doing the more advanced primary flight displays. Well, they can convert it to it later, but they don't, they didn't want to get in trouble with the common type certificate. So what they do is they put the round dials. Well, this occurred when Southwest was buying the 737s that were advancing from the basic, steam gauge round dials to the LCD displays. They couldn't get all the instruments on. In fact, they had an RMI that was only half of it on the bottom of the display there. And I kidded Boeing. I said, you need to put a little notch on the bottom of the display there so you can have the full circle there. They thought that was rather humorous. But that's a problem you get into when you try to put round dials on flat displays. But other than that, it's a fairly nice cockpit. Now, one thing, and it seemed to be a trait on some of these regional aircraft, the seats didn't have a J-track, which a J-track, the seat comes back and it goes over so you can get your chubby little legs in and out of there. Well, with just a straight track back, and you notice how close the seat is to the center console there. Right? You got to be twiggy to get in and out of this thing without getting your legs stuck there. So you pull the seat back. It's a little bit difficult getting in and out, but that's the way they designed it. Yeah, could use an improvement. That's why it's good to bring along airline pilots, because little things like, hey, you guys really should do a J-track if you have the room. The other thing that we found kind of interesting is on this aircraft. Test pilots fly shorter missions, stuff like that. They had no sun visors. Okay, I get sun visors in my Cessnas. To not realize it's an option. Okay, great. No, it's not an option. You need sun visors, and to think that you could put that as an option, boy, you're being mean to airline pilots, especially guys in the regional environment who fly, 20 hops a day, sort of these things. You need to have a few creature comforts there. But the aircraft is very nicely well laid out. This is the overhead panel, and it's got a big master caution panel there, as you can see at the bottom. And those are old school and going away for more of a display that brings you up with a problem and then puts the checklist like there. But that's how technology is advancing, and these guys kind of still have one foot in the past, unfortunately, one foot back in the 80s. But eventually all aircraft will come into this, and notice props are fading away because people are scared of propellers. They signify that either the pilots of the aircraft are subpar. But no, this is a very well designed aircraft, but it needs a little bit of polish on it. Let me put it that way, refinements. And this is the center panel. And here you can see it's a little bit better view. It's a little fold-out book they gave me, where you can see you got the round instruments there, which is a little bit more of a problem. But it's a nicely integrated suite there. And of course, this is why you have to do the electromagnetic testing, because you've got all these wires and cables and stuff like that. And you don't want, especially when it's electronic, you don't want stray electrons, microwave energy, electromagnetic issues getting in there and disrupting your nice displays, your avionics, and stuff like that. And here's a view of the throttle quadrant with the prop and condition levers there. Um, and the aircraft now, the interesting little thing, it's got a very nice hydraulic system with a lot of crossovers, backup pumps. You're not going to have, unless you have a massive leak, you're not going to lose hydraulics because you lose a pump. But the one thing about this aircraft that's changed is the elevator used to be manual, and because of certain reasons, they had to make it powered, hydraulically powered. The ailerons are the only control surface that is manual. But some of the guys, now we had 8 pilots total on this. I had myself and Jack, and then we had some more regional pilots, all to get kind of a feel for this. And one of the things they commented on, 2 of them actually, was they commented on the elevator. Since you didn't have manual feel, you lose a little bit of the feel for the aircraft, because a manual flight control, as you probably know, is a reversible flight control. You can feel the air pressure on it. The faster you go, the more you have to pull. So you get an artificial feel there. And sometimes, even on these type, they put in little devices to give you better feel, bob weights and all sorts of stuff. But the elevator, when you lose that reversible aspect of the flight control system, when it becomes irreversible, which is what a fully hydraulic system is, you don't feel the air load. So to get around that, depending on the aircraft design, they will put in artificial type of feels, springs and weights and all sorts of stuff to make it feel more like the aircraft is responding to the flight conditions. They do that artificially. And here is the electrical power aspect of it, which was reasonably well designed. Now, one thing I thought was interesting is that, boy, these guys are doing a real good job on backup batteries here. They have a main, secondary, and a backup battery. Well, no, not quite. The engines are started electrically, and you've got that 4,580 shaft horsepower engine up there. That's a big engine turning a big prop there. And that takes a lot of oomph to get that thing turned over. So it takes 3 good-sized batteries. They're talking about putting an APU on it to get around that little problem, which would be able to provide sufficient starting power. And of course, it because it's a turboprop, as such, they don't have a good bleed air source. And also, I'm sure there's probably something in keeping the common type rating here. They use boots. It's kind of like my Cessna 310. They use boots. Most aircraft with jet engines and a lot of bleed air, they go to the hot surface for de-icing, which I think works a lot better. But boots are sufficient in a certain respect, and there's the fuel system. Now, this was published in the May 1999 Airline Pilots Association magazine, My Flight Evaluation, and you see there is a turboprop aircraft on the cover. It's not the Q400 though, but I'm 2 from the bottom now, so not a bad position in the magazine as such. Now here's the flight evaluation as it appeared in the magazine, and I've attached this in the comments section. You can get the PDF file, and there are a couple interesting little things here. The aircraft actually sets 2 degrees nose low, and that is to meet evacuation requirements because this thing sets low. There's no evacuation slide, so there's a requirement of a distance to the ground that you don't get too high so people jump down. Now, our ramp weight for our flight evaluation was 54,000 pounds. The maximum ramp weight is 60,250 pounds, or they have a high gross weight version where it can go up to 63,250 pounds. And we had a fuel load of 9,270 pounds. The maximum fuel load is 11,830 pounds, which is about 1,740 U.S. gallons. The maximum landing weight is 59,750 pounds. Now, one thing interesting with these big engines, they were able to increase the cruise speed by about 100 knots true airspeed over the regular cruise speed. But interesting thing, this occurs at 17,000 feet. Well, the aircraft typically operates at flight level 270. Now, because it was early in the test program, don't have a real bunch of good cruise data at the time. We didn't have a bunch of good cruise data because, like I said, it's in the beginning of the program. For our takeoff, we could have used a number of flap settings, 5, 10, or 15 degrees, with various V speeds. For flaps 5, it had been V1 VR of 121 knots, V2 of 131. For our takeoff flap setting, we used 10 degrees, and it was a V1 VR of 113 knots and a V2 of 122 knots. And these speeds were 5 knots higher because they hadn't completed the stall and performance work, so they were putting in that 5-knot buffer to be, kind of safe. Now, the one thing I noticed, taxiing is always something that's very significant because that's your first indication to the pattern, to the passengers, that you can either fly this aircraft or not fly it. If you taxi out roughly jerking the people around, they don't have a very good opinion of you. And they use a taxi-by-wire system. Now, on the Airbus, they also have a little system. They have this little knob, and it can get to be a little touchy, especially on the longer aircraft. The first time I flew the 340, the Airbus 340, very long aircraft, I was pretty jerky on that nose wheel steering. But at the time, I was only a narrow body pilot, so I wasn't even used to taxiing a large aircraft. So yeah, that was part of my fault. I didn't know to be smooth. But I'm digressing here a bit. But anyway, okay, it uses a taxi by wire, and that can be a little problematic. You really got to set those things right. It uses a regular flat response up to 25 degrees a turn, because a lot of turns will be below 25, and if you really want to honk it around, you want the nose wheel to move. But unfortunately, they've got a bit of a knee there in it, where you get past the 25 degrees and it really ramps over. And so you're going through that little changeover, and you can get this little jerk back and forth, so that can make it not so smooth for the passengers, and you don't want that. That was kind of interesting. Now, I'm used to carbon brakes. And it was interesting to note that the other pilots who flew it were the more experienced Dash 8 pilots. I was the only non-Dash 8 pilot actually in the whole group. They were used to the steel brakes, and they had an interesting comment that I'd heard fairly often, was they felt the carbon brakes to them felt soft. But that's interesting because that's kind of a common response I hear from people that go from steel brakes to carbon brakes. Now, we used 90% torque. You get torque and RPM setting on these type of aircraft. We used 90% torque setting for takeoff. And if you have an engine failure, the auto feather system takes the engine out, which is a very nice feature. I wish my 310 did that. But the auto feather system takes the prop right out, and it takes the good engine to 100%. Now, one thing I found interesting on this as a pilot behind one of these aircraft getting ready to take off is one thing they do just before takeoff, and one thing we did, is you put the flight spoilers, you put the spoilers in the flight position. And what happens when you're on the ground, the spoilers come up. So you got a guy, he's number one to go, and all of a sudden the spoilers come up, and you go, "Hey, buddy, you got your spoilers up," So that can be a little bit of disconcerting because they'll taxi onto the runway, and unless you're another guy and you're a regular jet guy, you don't know about these turboprops, because they have those propellers. But anyway, you see this aircraft taxi on the runway with the spoilers up, and you think, "Oh my God, what's going on here?" It's kind of like the MD-80s with their tail is opposite directions. But they go onto the runway, and once you apply the takeoff power, the spoilers retract. They extend when you put them into flight for the ground check, but when you apply takeoff power, they retract. And they automatically extend then again when you get weight on the wheels. And like I mentioned, the spoilers are hydraulically powered. The rudder, the elevator now, which is a new thing, the elevator is hydraulic powered. And the only thing that's still manual are the ailerons. Now, this is a flight test aircraft. It's being developed, and it's interesting kind of little mistakes they made. They had the heading knob and the altitude knob were the same feel. And okay, you can, you change the feel, you can still grab it, the wrong knob. I've done that, but supposedly the feel is supposed to key you that you grabbed the wrong one, and they had them as the same, and that's kind of a, that's a thing that's developing. No, we make those different. So that's something they needed to work on. And also the light sensors in the cockpit, and I'm sure that the later Q400 pilots, I'm sure they got this figured out, but the display brightness would jump quite a bit, and that was not kind of a good thing. Other thing is the trim knobs were fairly conventional. They have on the center pedestal, they have a rudder trim. They have a rocker switch for aileron trim, but now the elevator trim is operated through a conventional switch on the yoke, which most people go, yeah, that's how you do it. It's fairly common. Well, the old Dash 8s, like the 727s and the old 737s, they have that wheel. And Jack was used to using that wheel for trim. That's how you do the pitch trim. You just kind of roll that guy a little bit, and it's a manual system, and it works quite well. And it was kind of funny. He kept placing his hand down there, and he says, I really miss the trim wheel. And another interesting thing, now I talked about ground spoilers, and it has ground spoilers, but it doesn't have in-flight spoilers. So, but the thing about you turboprop pilots, you know this well, you have this thing called beta. When you pull the power back, the blades go flat, and you've got two huge speed brakes out there. That's kind of the advantage on piston aircraft, is the blades will go fairly flat. Well, on a turboprop, you can actually make them go into reverse. Typically not in flight, although years ago I read a private pilot evaluation of this guy doing a Husky or something that had the single engine turboprop, and he's trying to do a short field landing, and he pulls the thing, he thinks into flight idle to slow it down. He actually goes into reverse, and then he talks about how he taxied up to the runway because he ended up landing short of it. Fortunately, not a landing that would have put the gear up through the wings or anything like that. But anyway, I was doing an evaluation of the descent rate, and being a flight test aircraft, we can, do various things, and I pulled the props to idle, so I got the blades flat to look at it, and the barber pole is at 286 knots indicated, and I went intentionally past it to evaluate the overspeed warning and the characteristics. Now, it was kind of interesting. The overspeed warning sounded more like a gear warning horn. Now, I have experienced in flight test and operationally, I have experienced overspeed warnings that were oral speed warnings, repetitive chimes, clackers, beeps, and horns. One thing that we try to do on these committees in flight test and being involved in certification and stuff like that is we try to harmonize these warnings. So when a pilot transitions to one aircraft for other, there won't be confusion where he's doing an overspeed and he thinks, well, why am I getting a gear warning here? That can be a little bit disconcerting. And you can read more details in the magazine article. Like I said, I've attached it. But we went and we did some stalls, clean and dirty, and the airplane was very responsive in pitch and roll. It tended to wallow a little bit when I applied the power, but that's because these engines can come up unevenly when you put a high demand in there, and a little bit of difference can give you kind of a wallow in it. And I did some single engine performance work. I did a situation where Warner pulled one of the engines to zero thrust. It was still very controllable, but the thing was, it was in a go around situation. I had to very noticeably lower the nose to maintain V2, which isn't unusual, but it took a very concerted effort to put the nose down. I did a couple of 6-degree bank-to-bank rolls to determine the roll rate, and it came in at a respectable 30 degrees per second. It's not like the T-38, 720 degrees per second, but it's not a T-38, and the passengers would certainly not approve of that roll rate. Some interesting things about the RPM. They like to cruise at 900. Now RPM, the prop speed influences the noise in the cabin. So the lower the RPM, the quieter it is. That's why a 421 with the low cruise speed is a very quiet aircraft, as opposed to my 310, which is a bit noisier because the RPM is higher. I'm digressing, I know. But anyway, those are kind of the facts of that. Now, one thing, when you come into land, you bring the props up, and that's kind of a it can be disconcerting for the passengers because you've increased the noise bit quite a bit. But anyway, I'm coming back, and I'm going to do some patterns. And the first landing I do, I perform what I consider is a pretty normal flare. Now you got to remember, you can look at the picture. This is a long aircraft, and they try to extend the gear as much as they can. The trouble is, when you get a long strut like that, now it gets a lot harder to make a smooth landing because of that long strut throw. Always good to know what your excuses are as a pilot, okay? But it's nice when you got an aircraft that helps you out. But it was hard to make a smooth landing. But I come in for what I consider is a normal flare, and I rotate to 6 degrees nose up, which I considered a reasonable pitch attitude for the flare. And I noticed Warner became rather concerned about that. Well, I found out that the tail strike pitch attitude is 8 degrees, so I was getting close to that. So it was kind of no wonder that he wasn't too terribly excited about that. Now I did a flaps 15 takeoff, and as I became airborne, Warner pulled an engine to zero thrust to simulate a engine failure. Of course, zero thrust is the prop thing for simulating a fully feathered prop, and of course we don't want to get necessarily that involved where we'd actually feather the engine. Of course, they have to do that in flight test. But this is a little more situation where we're not going to quite get ourselves in that bind. But the aircraft was very nice to fly, and single engine, speed is life. And I was coming around, and I had about 10 knots extra speed. So I haven't flown turboprops a whole bunch. I've done a few flight evaluations on the Dornier 328 prop and the ATRs and stuff like that. I've flown them some, but I'm mostly a jet guy. And I'm coming in, and I'm a little fast on speed, so I pull the power to idle. Well, idle goes flat pitch like that. Jack's in the jump seat back there, and he goes, "Oh boy," which, now let me translate that for you. "Oh boy," from a member of my committee to the chairman, who is me flying, is a way of saying, "Boss, you just screwed up. This is going to be an arrival." Fortunately, I realized immediately what I'd done, because you can tell the airplane is decelerating, and rather rapidly. So I had enough speed that I could milk the flare, and I actually got a nice landing out of it. But I knew what I had done. But the nice thing about it, I could get full reverse on the one good engine to aid in stopping, and you can't do that, I guess, on the previous models. But the one thing about an airplane like this with the big props, on a jet engine with a reverse thrust, you got to worry about ingesting stuff, so you can't do it down low speed. Well, you got to worry about picking up stuff with the props too. But the deal is, reverse thrust on jets isn't all that efficient, and with carbon brakes, you don't need it that much anyway. The carbon brakes take up a lot of it. They do the stopping for you. But the thing with these airplanes is the reverse thrust is so powerful. It really brings you to a stop quickly. But it was kind of interesting, the getting the feedback. Jack, of course, I let Jack fly it, obviously. That's what I brought him there for. And he commented that the Q400 had a heavier feel in pitch and roll than the Dash A200 that he was used to flying. He had 12,000 hours in those. But what happened is Bombardier had to stiffen up the flight controls because the Q300 exhibited almost neutral stability during the 1.13 via side slips. That's, the thing doesn't have any riding tendency, and you want the riding tendency. You don't want neutral stability, and you definitely don't want negative stability. So they had to do the heavier control forces to ensure that you would have positive aircraft stability, as well as to enhance the flight control harmony. You don't want, it take a lot more force for putting in ailerons than it does in pitch, because that doesn't give you a good handling aircraft. But it was kind of interesting to note Jack's comments. He noted a few minor differences between the 400 and the Dash 200, such as electric versus manual trim, and because he really liked to kind of roll that wheel. And if you're a good pilot, you can just really kind of mount that trim wheel just right to get the trim right where you want it. Electric trim, it's more incremental. It can be harder. The one thing on the 777 is actually if you were in 5 knots of trim speed and you click it, it automatically trims it. So that's a little thing that I think most 777 pilots may not even be aware of, but it makes it easier to trim. Okay, back from digressing there, but he also noted that they had this little, the more modern slip indicator on the electronic flight instrumentation instead of a big inclinometer that he had on the other aircraft. And it was kind of interesting to note how the other Dash 8 pilots commented about how stiff the landing gear was and kind of prevented them from getting good landings. And it's another interesting thing that anybody who flies little airplanes, you got a nice feel with a reversible manual elevator on an aircraft. And the pilots were kind of bemoaning the fact that going to hydraulic, they lost that nice little feel. Now, somebody who flies a regional aircraft like a turboprop, a lot of these short hops, they usually become pretty good pilots and develop a really good feel for it. It's not like those of us who set 18 hours and get one landing, and we're half asleep when we do it. But I must admit, I think I get my best landings when I'm half asleep. I'm nice and relaxed. I try to overdo it when I'm awake. Anyway, digress. But one thing that they made, one reason they made the aircraft hydraulic powered also was to allow a greater range of CG and to meet control for certification requirements for tailplane icing. And tailplane icing is a big issue on these aircraft. That's that and the other comment that the symbology on the avionics was a little dated, and it would be nice to see an improvement there. But overall, we had a very good flight, and Alaska Airlines flew it, and you probably know that's a picture of their senior flight attendant on the tail there. Okay, don't write, no letters. Okay, on that one, that's the old joke. But anyway, it's a very good aircraft for the type of performance that it was meant to do, the 400 mile stage lengths, around that, where turboprops are just more efficient. Of course, like everything, now 25 years later, you don't see a whole lot of turboprops out there. But anyway, that is my last propeller other than the Boeing 247, which was my very last flight evaluation as chairman of this committee. But this is the last regional type propeller flight evaluation that I did. So I hope you found it interesting and enjoyable. Thanks for watching.